Signal sampling. So what is it and why is it useful? Well, basically, it's just a way in which we can represent real-world things like light and sound in a language that computers will understand. So real-world data or things is called analog, and computers like to deal with things in digital form. So these are two words that are thrown around a lot, but what do they actually mean and how do they relate to each other? Well, I think the easiest way that people will intuitively understand is to think about a clock. So we've got numbers all the way around the outside, and we've got three hands, a minute, an hour, and a second hand. For simplicity's sake, let's just take a look at the second hand. So this just moves around the clock. Every second, it's pointing at a different place around the clock. So if we were to blow this up slightly and take a closer look at what's actually going on here, we might see something like this. So we've got round the edge of the clock like that, and we've got the 12 here and the 1 here. And in between, we have 1, 2, 3, 4, 5 little markers, each representing a second. So now the second hand points to one of these. On the very next second, it's pointing to the next one. On the next second, it's pointing to the next one, and so on. And it just keeps going round and round. But now it's easy to see from this that for the second hand to move from this point to this point, it has to move through that path. And in doing so, it's going to point to all of this space in between these two second markers. Now we could split the space between these second markers into smaller time divisions, maybe 1,000 time divisions, and that would, each of those time divisions would represent a millisecond, or maybe we could do 10,000 or 100,000 or a million, or an infinite number of time divisions. And this second hand, in moving from point A here to point B, has to point to every single one of those time divisions. So we could point with this second hand to 1.379562 seconds, for example, if we wanted to, or any arbitrary second value down to as many decimal places as we want. So that's what analog representations are. They can represent data in infinite number of ways, down to infinite accuracy, where on the flip side of this, we have digital clocks, which of course don't have hands. They just have numbers. And we might have something like this, 12, 37 in seconds down here, and 48 seconds. And then that'll go to 49 seconds, and then 50 seconds, 51, etc. But here, if we wanted to represent 48.336 seconds, we can't. There's just no way we can do that on this digital clock, because it just ticks from 48 to 49. So when time is actually at 48.336 seconds, our digital clock is only going to say 48, and then just tick to 49. So we're losing accuracy here, but the trade-off for a loss of accuracy is now we only have a finite number of possible ways of representing the data. Because we can see here that the digital clock and the analog clock are representing the same data set. One can just have infinite accuracy and the other has only finite accuracy. But the benefit of finite accuracy here is that we now only have a finite number of values which a computer can deal with. So if a computer doesn't like infinity, because a computer is a digital thing. So now if we're to look at a real world example, maybe we have a microphone, and the microphone's listening to some music. Got the nice little microphone and it's listening to some music. Now music, of course, is a real world thing. It's analog data. We could go down to infinite time divisions or infinite sound pressure divisions, and there will be a valid value. So we could draw it here. Maybe we've got time and sound pressure. And we've got a graph that maybe looks something like this. And say this time here is 1 second. We could split this into time divisions, an infinite number if we wanted to. And we could trace up from one of these time divisions, and there will be a valid sound pressure. Trace up from another one, there'll be a valid sound pressure. And we could go down to an infinite number and trace up, and there's always going to be a valid sound pressure. So this is an analog signal. But we need some way of representing that as digital data, because we need, maybe this microphone is plugged into a computer, so it needs to be digital. So this is where sampling comes in. This is the whole point of sampling. So now if we're to just maybe think about the word sampling, you might think about a survey. And the people doing the survey ask a sample of people some questions. And that sample of people is meant to represent the entire human population, or the entire population in that given area. And the answers that that sample give is used to then provide an approximation to the opinions of everyone. So a small part of something is used to represent an approximation of everything. Now maybe another example. We have a basket, and inside this basket we have lots of balls. Now these balls might be different, they might be the same, but we don't know this. But we want to find out. So we could just trawl through all of these balls and record all of the characteristics, but that's very slow. A more efficient way might be to just pick out a few and take the characteristics of them and then use those characteristics of those few, that small sample, to approximate the characteristics of all of the balls. So now, if we take this idea back to this signal, how could we take small parts of this to represent the signal, the whole signal? So maybe we take some parts, we just mark them on here. Some parts equally spaced all the way around here. So we've got that. So now we can forget about all of this stuff in the middle. All of the pink line, we can forget about all of that. So say if we were to redraw this graph and just plot our sample points, we might get a graph that looks something like this. Now that looks very similar to our original analog graph, but the difference now is we only have a finite number of values. If we go to this time and trace up, there isn't a known value for that sound pressure. We've just got to interpolate between there and assume a value, but we don't know for sure. We have to just assume what the value is there based on the interpolation between the points. But now that we've got a finite number of points, a computer can represent this. This is digital data. So that's all sampling is just taking a small part of an infinite number of possibilities in a signal and using that as an approximation to the whole signal. But we do lose accuracy doing this. But that's a small trade-off for allowing a computer to represent the data.